Hello and namaste. In continuation with the linear algebra topic, matrices will be going ahead with the rank of a matrix by reduction to a normal form. After just going through the definition and the detailed properties of rank of a matrix, we have to go because it's not feasible every time to go and use the rank of a matrix. Rank of a matrix says the definition says that higher or highest order non-zero determinants. So it's not possible or feasible to go for the higher order matrices to find out the rank of that particular matrix. And that is the reason normal form is one of the method to find out the rank of a matrix. So what is the theorem? Theorem says that any matrix of order m cross n can be reduced in the form IR00. Just you read it for a while, because these are the things, or IR0 or IR0 or IR. So sometimes it is a square matrix of this kind of thing. Then it might be a row, might be a column, might be a square matrix by elementary transformation. So here we'll be using the row as well as the column transformation, both, and column. So we are using both the transformation in this particular method, where R is the rank of a matrix. So what is this IR? IR is nothing but identity matrix of order small r, or otherwise I can say order R, right? And that means what this, and this is what is this R? R is referred as the rank of a matrix. R is referred as a rank of a matrix. Now this form is known as normal form or first canonical form of a matrix. Now let me explain you all of them, because this particular theorem contain only this particular first form. Rest of the forms I have included according to the situation, because what is it? Most of the time the learners would get confused that this type of form is not there, but something like this is there, something like this. So how this all the forms will look like? Let us see that. So now if I'm going to see, this is my after the row transformation and column transformation, I have got this as a normal form or the form. So this I have to partition, put a partition on this, and this is equivalent to, so this is what? This is I2. What is this 0, 0? It's a row matrix with a 0 element, everything. Then, sorry, a column matrix with a 0, and this is also a row matrix with 0, and this is the row, and this is known as a partition of matrices. So we are, after doing the partition of matrices, I'm going to get this form, which look like something like this. And this implies what is the value of small r? Small r is here, that is 2. So small r or rank of a matrix is equals to 2. So I have to look at the order of the identity matrix over here. Similarly, if we'll observe this particular thing, so it's again a partition. This is going to give me I2 0, right? And this is nothing but again here. So this is the rank small r. So I2 R. So rank, or otherwise most of the time the rank referred as row of A is equals to 2, and few of the books are saying RANK, rank of A is equals to 2. So these are the few notations. Okay. Then if I will go ahead with this type of thing, so it is looking as I2 0. So it looks like a column. And again, this is because of this 2, this is the small r value, or you can say the R rank of a matrix is equals to 2. Similarly, this is the last form wherein you will observe here, this is equivalent to I3. There is no other elements or other row or a 0 rows or a 0 column present here in this particular matrix. And this is nothing but, this 3 is nothing but the rank of a matrix or the value of small r. Let us go and see this particular example with the help of this normal form with the help of example. I'll be giving you an algorithm which is, you can follow it very well and you can just get these things done. Let me change. This is okay. Because I don't want the very dark color, I just would like to have a little light color so that I can explain. Okay, so now if we'll observe in the previous case, so everywhere we have got here 1, we have got it here 1, we have got it here 1, we have got it here 1. That means what? If at all I have got this as my matrix of any order, so I should be able to form that identity matrix somewhere here in the corner, in the left corner. So it has to be something IN here, right? It might be zeros here, it might not be zeros, or might not be zero columns or zero rows present here. But I have to take it in. So if I'm taking this as IN here, or the identity matrix, so that means what, my this element, first element always has to be equals to 1. So one element has to be always equals to filled with 1. Rest of the things should be equals to 0. Similarly, if you observe here, this is zeros, this is zeros. Then it is a 1 over here. This is 0, this is 0, and here it is a 1. Then now this in the second, 1 is here. So below that everything is here, 0. Then the next to that particular columns, again it is 0. Similarly here, if you observe, this is 0. Again, if you look at this here, zeros here, zeros here. If this is an element of 1 here, below that is 0, above that is 0. Then here also 1. Similarly, in this particular case also, you can see that this is nothing but a normal form. So you will get an idea that what exactly we have to do it. We'll be doing the same thing in the one of the example. 1, 2, 3, minus 1, minus 1. So this is the matrix given to us, and this order of a matrix is 4 cross 4. So what is the highest order? Highest order possibility might be R equals to 4. But it is a highest order non-zero determinant. So now I have to see, and I have to look at that first element have to be filled with A11. Element have to be filled with 1. Now it is already there. So what is my next task to do is, next task is to complete this 0, this 0, and this 0. But it is already 0, so I need not to worry about this particular element. So I want this as 0, this as 0. So what would be the transformation? Because in this particular first element, I have to take the help of this particular 1. I have to make this as 0, make this as 0. So the transformation would be R2 plus R1. This R2 plus R1 would give me this particular element as 0. So I'm targeting only one element. The other element I'm not going to worry. What these other elements would come. We will concentrate on other elements later on. So now this is what we have got it 0. Then, so it is minus 1 plus 1, 0. Minus 1 plus 2, 1. Minus 3 plus 3, 0. Minus 1 plus minus 1 is minus 2. There is no change in the row R2. So this first transformation is changing our R2, that is the second row. Second transformation would change the R3, that is the third row. Now if you observe the third, R3 minus R1 is the transformation. 1 minus 1 would give us 0. So this row is changing. Then 0 minus 2, minus 2. 1 minus 3, minus 2. 1 minus of minus 1 is 2. So we have got this R3 row changed. There is no change in R4 because we have not chosen any transformation for the fourth row because we don't want it. It's already filled with 1. Right. Now if you'll observe here, we have got the first row here 1, and then I have got this remaining elements as 0. So what is my next task to complete? Next task is to complete this 2 as 0, this 3 as 0, and this minus 1 as 0. So that we can do it here by doing the column transformation as C2 minus 2 times C1, C3 minus 3 times. So let me just concentrate on this particular one. So this is changing my C2, that is a column 2. Let me just put the arrow from down here. So if this is going to change it. Now how that would change? 2 minus 2, because it's C2, it's 2, minus of 2 times C1. So it's a minus of 2. So 2 minus 2 would give me 0. So I've got it 0 here. Then 3 minus 3 would give me 0. Yes. Minus 1 plus 1 would give us 0. Now what about the next element? Next element is 1, right? Now 1 minus 1 or 0, sorry. 1, 0. 2 minus 2, 0. 1, 0. So that means what? These elements are already present here as 0. So that means what? There is no change on this particular matrix inside the matrix. So I have got this as 0. I've got this is also 0. And this as my first element as 1. Right. Now I have to look at to the next row, which is this element have to be equals to 1. But we have got it's already 1. So if it is already 1, I have to make this minus 2 as 0. This 1 as 0. Using the transformation R3 plus 2 times R2 and R4 minus 2 times, sorry, R4 minus R2. So this would give us the corresponding elements would also change according to this one. So if you observe this, we have got it 1 here, and below that everything is 0. What is to be left? This is already 0 here. So I have to make this minus 2 as 0. So the transformation, please do the remaining things here. I'll just because every element, so this transformation you're going to do it on this particular R3 row. So this transformation is changing my R3 and this transformation is changing R4. Similarly, in the previous case, this particular second transformation will change C3 and this will change C4. That is a column 4. Fourth column, third column, second column, third row, fourth column, right? So these are going to the changes in particular thing. Now the next task is to make this -2 as 0. That can be done. This is the element on the fourth row and we have to take the help of the element which is placed in the C2 column, right? So C4 plus 2 times C2. So now C4 plus 2 times C2 would give us this -2 plus 2 as 0. So we have got it as 0 here. Now the next task is to make this here as 1. Yeah, and it is possible because it's a -2 -2. No fraction is coming. Try to avoid the fractions in this type of examples so that sometimes it is not possible to avoid it. But yes, whenever it's possible, just go and please avoid the fraction so that it would be easy for you to go ahead with the calculation. So now we have left with this. So -2 can be placed or can be changed as 1 by putting the transformation as -1/2 times R3. So after making this is the change over here. This is the change over here, right? Because we are changing or we are dividing R3 row by -1/2. So otherwise we are multiplying it with -1/2. So after making it, we have got this 1 1. Now what is to be left? Now next task is to complete this 1 is here. I need to make the changes in this particular. So I have to change this 1 as 0. What is the transformation? R4 minus R3. R4 minus R3 would give us this 0 0 because if you observe 1 1 1 1. So R3 minus R4 minus R3 would give us this type of particular. Now what is the next? Next is to make this as 0. This would be done as C4 minus C3. After making C4 minus C3, this element, if you observe, this is equals to 0. So now how to check whether this we have received the normal form or not? So this is 1, below that is 0, this is also 0, then this is again the first element as 1 in the next row, then this is this one, then this is 1 over here. Now this is the 1 here, below that is also 0, next is also 0, and there is no element here, right? Element here or any non-zero element here. Okay, now if I wanted to have the partition of this particular type of matrix, so I have to do the partition something like this here, right? So I have to do the partition like this. So if I'm making the partition like this here, I'm going to get this is equals to this. So this form is nothing but as I3 because it's 3 cross 3 identity matrix here getting formed, and 0 and 0. I think there is okay. I think I have messed out that. So it's a 0 0 here, right? The form would come something like this, and this would give us rank of A is equals to 3. So because of these elements present here, we have to write down here this form as I3. Please make the change here. This would look like this: I3 0 0 0, and rank of A is equals to 3. So we have got it as 3 as a rank. Just will go quickly with this particular example. Now again A. Take this first element, this is filled with 1, so I need to make this 3 and -1 as 0 by going for the transformation R2 minus 3 times R1, and this is changing my row R2, and this is the changing, there would be a change in R3 row here, right? R2 row is changing by R2 minus 3 times R1, so 3 minus 1 0, 3 minus 3 0, 4 minus 6 would give us -2, 0 minus of minus, so plus 3 would give us 3 here, right? Then minus 10, so it's -1 minus 9 would give us minus of 10. First row, no change, so this is a change in the R2. Similarly, you can do the same transformation. So -1 plus 1 0, 0 plus 2 2, -2 minus 1 minus 3, 7 plus 3 10. So we have got the R3 row also changed. So if you observe, first row Below that, everything has been come as 0. So now next task is to make this 2 minus 1 and this 3 equals to 0. How can we do that? We can do this by R3 plus R2. I think I'm missing something over here. What is that? Or I think we have done it. Fine. Okay, no problem. Just let us go with a little bit of different. R3 plus R2 would be, because why is that so? Because it's a minus 3, 2 minus 3, and this is minus 10. So they are exactly opposite to each other. So if they are exactly opposite to, actually there is no need to go for that also. So but there is this, if this we are going for this particular type of way, that is also correct. Then this 2 minus 3 10, so this is 0 0 0, because of R3 plus R2 will give, because they are if you observe these two elements over here, they are negations of each other. That is the reason R3 plus R2 will give us this particular row. As I have told you here, this is 2 minus 1 and 3 needs to be equals to 0. That can be done it here. C2 minus 2 times C1, C3 plus C1, and C4 minus 3 times C1. So that can be done it here by using this, and you will be getting it. This is 1 here. Next 0. Below is also 0. Now I have to make it this minus 2 as. Okay. Then because it's a column, every column contains one element. So if you observe one element, and one element. So one transformation can be done. Minus 1 by 2 times C2, 1 by 3 times C3, and minus 1 by 10 times C4 would give us 1 1 1. Now it's easy for us to just go ahead with the transformation. C3 minus C2, C4 minus C2 would give us. So that means what? So we have done this as 1, and this has to be 0. This has to be 0 by choosing this transformation. C3 minus C2, C4 minus C2, and we have got this as first row. Below that, zeros. Next also zeros. This is 1, below 0, next also 0. Now we have to do the partitioning of this particular thing. So after doing the partitioning over here, if you'll observe, we have got it here, I2 0 0. So these are the part. This is 1 0, this is another 0, this is a third 0. 1 2 3 I2, right? And therefore the rank of a matrix capital A is equals to 2. So this is what you can do it. Now here a little bit of shift, or little bit of, you can say, the swapping of the few terms or few things, you can do it, and you just reduce your calculations further, right? Okay. This is a self-observation slide for you all. Yeah, and this is a self-observation slide wherein 2 questions has been given to you along with the answers. Write down, try to find out the normal form by what we have discussed now. So now if you observe here, this is a 0 element here, but we don't have any 1 here. I need to bring this 1. So I can do it just by swapping these 2 columns, or I can do it just by swapping this and this row. Even there is another chance that we can do it by this also. So just swap these 2, and you can just reduce your calculations by bringing it 1 over here, either by column transformations or a column swapping, or the row swapping can be done, right? Okay, so this is all about the normal form of the reduction of a normal form, and find the rank of a matrix. I hope you have understood. If at all you have any query, please let me know in the comment section so that I can help you out. If you like the video, please hit the like button, and if you really just love to go ahead and learn from me, subscribe the channel. Thank you. Happy learning.